The current state of large language models, LLMs, has led to significant improvements in understanding and generating complex mathematical content. However, the availability of high-quality, varied, and difficult mathematical questions is dwindling. Relying solely on human experts to create new questions is not scalable, while LLM-generated questions often lack diversity and difficulty. To address this issue, a design framework is proposed that combines the strengths of LLMs with a human-in-the-loop approach to generate a diverse array of challenging math questions. The framework leverages LLM metacognition skills to extract core skills from existing math datasets, which serve as the basis for generating novel and difficult questions. The use of two very different skills within each question makes finding such questions an out-of-distribution task for both LLMs and humans. The pipeline employs LLMs to iteratively generate and refine questions and solutions through multiturn prompting, with human annotators verifying and further refining the questions. The proposed framework is applied to the math dataset, resulting in the creation of MATH2, a dataset of higher quality math questions. The performance of all models on Math2 is lower compared to math, indicating the increased difficulty of the questions. Additionally, using Math2 questions as in-context examples leads to higher performance on math. A striking relationship is observed between models' performance on the new dataset, with the success rate on Math2 being the square of the success rate on math. The evaluation saturation phenomenon is also discussed, where LLM evaluations become saturated due to across-the-board improvements and evaluation-specific enhancements. The distinction between general and evaluation-specific improvements is crucial, as the latter may lead to overfitting to particular evaluations rather than a genuine acquisition of mathematical skills. The proposed framework aims to address this issue by generating novel and difficult questions that require a non-trivial combination of two distinct math skills. The use of LLMs to generate and correct novel questions that they are unable to solve themselves may seem counterintuitive. However, recent research has demonstrated that top LLMs possess a robust understanding of mathematical skills, including the capability to identify the skills required to solve given questions. The proposed framework leverages this capability to generate math problems when given a list of skills that have to be tested. The AI-assisted question generation pipeline involves a 5-step process: skill pair validation, question generation, attempted solution, question validation, and final solution. This pipeline leverages human expertise and large language models, LLMs, to generate high-quality, novel questions that combine distinct mathematical skills. The process begins with skill extraction, where mathematical skills are identified and cataloged from a dataset. The pipeline then generates questions that combine pairs of distinct skills, increasing their difficulty and requiring out-of-distribution thinking. The use of random pairs of skills is crucial for improving diversity and difficulty among generated questions. This approach necessitates the application of two distinct underlying skills, making the questions more challenging for both LLMs and human raters. The generated dataset, MATH2, is significantly harder than the existing math dataset, with a success rate of 0.25 for models that achieve a 0.5 success rate on math. The pipeline's performance is evaluated using various open-source and proprietary models, including GPT-4, Claude, and MetaMath. The results show that models demonstrate lower performance on Math2 compared to math, with proprietary models exhibiting smaller performance drops. The paper also discusses the importance of human-AI collaboration in generating novel evaluations and the potential for introducing fresh perspectives into math instruction. The pipeline's design methodology and generation process are detailed in Section 2, while Section 3 discusses the performance of various models on math and MATH2. Section 3.2 explores the relationship between math and Math2 scores, and Section 3.3 demonstrates the usefulness of Math2 questions as in-context exemplars for LLMs. Section 4 sheds light on the interesting behaviors and failure modes of leading LLMs observed during the question generation process. The pipeline's structured approach to generating challenging mathematics questions combines the strengths of LLMs and human expertise, ensuring a comprehensive evaluation framework. The use of advanced techniques like in-context exemplars and self-consistency ensures the accuracy and quality of the solutions, maintaining the integrity and reliability of the generated questions and their solutions. The paper presents a 5-step approach to generate difficult math questions using advanced models. The process begins with skill pair validation, where the model assesses the qualitative similarity of two skills and excludes similar skills to ensure high-quality questions. Next, the model generates a question and a brief solution requiring the application of both skills in the sampled pair. The model then attempts a solution to the generated question, identifying flaws such as insufficient information, ambiguity, self-contradiction, or excessive computation. If any issues are found, the model stops solving and clearly states the problems. Otherwise, it completes the solution. The generated question and its solution are then validated against a fixed rubric consisting of 7 criteria: single answer requirement, exact answer requirement, dual answer requirement, clarity and completeness, computational tractability, realism and logic, and syntax and grammar. The model uses reference examples and validation exemplars to facilitate this step. For questions classified as valid, the model resolves the question to obtain a final solution. Reference examples are provided in context to improve the model's understanding. If all the answers obtained in this step are unique, indicating potential ambiguity, the question is discarded. The questions obtained from the above pipeline are further screened by humans. This structured approach not only generates challenging and novel math questions but also ensures their quality through rigorous validation, effectively combining the strengths of AI and human oversight. The paper also demonstrates the difficulty and quality of the Math 2 dataset by comparing the performance of various models on Math 2 and Math. The results show that the Math 2 dataset is necessarily harder than Math, with models demonstrating a significant drop in accuracy when tested on Math 2. The research paper presents a comprehensive evaluation of various machine learning models on a newly generated math dataset, Math 2, which combines skills from different subareas of math. The authors compare the performance of these models on Math 2 against their performance on the original math dataset. The results show that all tested models have significantly lower performance on Math 2, with a percentage drop ranging from 13.42% to 35.45% for frontier models. A surprising pattern emerges when plotting the performance of models on Math 2 against the square of their performance on Math, revealing a linear relationship, y approximately equals x2. This implies that the relative drop in performance of the models is well predictable from just their performance on Math, without considering their training details. A heuristic explanation for this relationship is proposed, suggesting that the questions in Math 2 genuinely require applying two distinct skills, and that the y value will be the average value of the product of the success rates of the models at correctly applying these skills. The authors also investigate the effectiveness of the generated questions as in-context exemplars for the math dataset. They propose a new procedure to retrieve in-context exemplars from Math 2 based on the skill requirements of the current question. The results show that the generated questions serve as effective in-context exemplars, outperforming two baselines. The performance gains are attributed to the difficulty and skill relevance of the Math 2 questions. The paper highlights the importance of human raters in improving the generated questions, as models may fail to follow instructions or create interesting and creative questions. The authors also discuss the limitations of their approach, including the need for larger datasets generated using their pipeline to reduce the need for external exemplars. Overall, the research presents a novel approach to generating math questions that require applying multiple skills and demonstrates the effectiveness of these questions as in-context exemplars. The proposed framework leverages the strengths of humans and AI to generate new, challenging mathematics questions. It utilizes large language models, LLMs, to extract and name key skills necessary for solving math problems. The framework involves a human-AI synergy, where LLMs generate questions and human annotators refine and improve them. Table 3 presents the performance of various models on the math dataset under different prompting strategies. The results show that few-shot prompting with exemplars retrieved from the generated set of questions, Math 2, consistently outperforms vanilla few-shot prompting, with gains of up to 3.75%. The proposed 4-shot prompting strategy, which involves retrieving exemplars from MATH2, achieves the best performance. The framework also enables the creation of creative and challenging questions through human-AI interaction. Human annotators verify the validity of the questions and the correctness of the solutions, ensuring that the created questions employ the intended math skills and are readable, of high quality, and difficult. Examples of such questions are presented, showcasing the ability of the framework to generate novel and interesting problems. However, the framework is not without limitations. Models frequently exhibit failure modes, including insufficient involvement of skills, insufficient information, unsolvable or computationally intractable questions, nonsensical questions, deceitful solutions, and finding a needle in the haystack. These failure modes are discussed in detail, along with examples of questions that exhibit these issues. The framework highlights the essential role of human oversight in refining and improving the questions generated by LLMs. Human annotators play a crucial role in ensuring that the created questions are challenging, creative, and suitable for advanced mathematical problem-solving. The framework has the potential to generate new, challenging mathematics questions that can be used to evaluate the reasoning abilities of LLMs and humans alike. The paper discusses the development of a pipeline that leverages named skills from the math dataset and multiturn interactions with advanced LLMs to generate questions combining pairs of skills. These questions were reviewed and refined by human raters, resulting in a new math evaluation Math2 that assesses the same skills as the math dataset but is significantly more challenging for leading models. The proposed pipeline produced questions with greater novelty and difficulty compared to those in the original math dataset. GPT-4t and GPT-4o exhibited the smallest performance drops, which aligns with the subjective evaluations of our human raters. Additionally, providing the newly generated questions as in-context examples improved GPT-4o's performance on the math dataset more effectively than examples sourced directly from the math dataset. This finding further validates the quality of the questions produced by the proposed pipeline. Open-source models performed disappointingly on these new questions, but this weak performance also suggests that their performance should be improvable using novel questions of only moderate difficulty which our proposed pipeline can generate at scale. The authors plan to release detailed information about their pipeline to encourage further research and development in the field of open-source math models. Limitations and future work include optimizing prompting strategies to produce higher quality questions initially, reducing human verification through the development of automated validation tools, and enhancing the pipeline by integrating a training-based feedback loop. These measures will reduce dependency on expensive proprietary models, lower overall operational costs, and maintain or even enhance the quality of the generated math evaluation benchmarks. The potential application of the proposed framework to efficiently produce high-quality data in domains beyond mathematics is also discussed. The paper discusses the development of a new AI model, Gemma, which is designed to be more efficient and effective than existing models. It also introduces a new dataset, Open Math Instruct 1, which contains 1.8 million math instruction tuning data points. The authors highlight the importance of using this dataset for training and fine-tuning AI models to improve their performance in solving mathematical problems. The paper also presents a novel approach to solving geometry problems without human demonstrations, using a model called Solving Olympiad Geometry. This model has been shown to achieve high accuracy in solving complex geometry problems, outperforming human solvers in some cases. In addition, the authors discuss the use of chain-of-thought prompting to elicit reasoning in large language models. This technique involves providing the model with a series of questions that require step-by-step reasoning to solve, and has been shown to significantly improve the model's ability to generate accurate and logical responses. Furthermore, the paper introduces a new evaluation framework for AI models, called Skill Mix, which is designed to assess the model's ability to combine multiple skills in solving complex problems. The authors also present a new model, MetaMath, which can generate mathematical questions based on given skills and can be used as a tool for creating customized math exams. Finally, the paper discusses various failure modes of the question generation pipeline, such as insufficient involvement of skills, insufficient information in the questions, and unsolvable or computationally intractable questions. The authors provide strategies for mitigating these issues, including the use of multiturn human-AI interactions and explicit clauses in the question validation prompt. The research paper discusses the challenges of evaluating the reasoning abilities of large language models, LLMs, through question generation and validation. The authors highlight the importance of filtering out questions that require brute force calculations, as they do not effectively assess the model's reasoning abilities. To address this, the authors introduce an explicit condition to check for computational tractability and solvability of generated questions. The paper also discusses the issue of nonsensical questions, which can be confusing, incomprehensible, or logically inconsistent. The authors provide an example of a question that is logically inconsistent and describe how they add checks to the question validation prompt to detect such cases. Additionally, they discuss the problem of deceitful solutions, where the model makes up solutions to nonsensical or unsolvable questions. To address these challenges, the authors develop a sophisticated validation prompt that includes skill descriptions, validation exemplars, and conditions to check for dual skill requirement, clarity, completeness, relevancy of information, and realism. However, they note that the model can still struggle to locate the original skill names and may confuse the pair of skills at hand with skills mentioned in the validation exemplars. This is attributed to the lost in the middle, or finding a needle in the haystack, challenges faced by LLMs. The authors provide an example of a question that requires the application of two distinct mathematical skills: probability theory and number theory. The model's reasoning trace demonstrates a rigorous application of both skills, but the authors note that the model can still make mistakes, such as checking the question for the presence of unrelated skills. The paper highlights the importance of carefully designing the validation prompt to ensure that the model is evaluating the correct skills and not getting lost in the complexity of the prompt. The author's approach involves replacing referential terms with skill names to nearly eliminate the problem of the model confusing the pair of skills at hand. The paper discusses the development of a system that uses large language models, LLMs, to generate math problems and their solutions. The system is designed to mimic the thought process of a math teacher, creating questions that test students' reasoning and analytical skills. The authors highlight several failure modes, such as generating questions that are too difficult or too easy, or that require brute force computation rather than reasoning. To address these issues, the authors introduce a validation step where the generated questions are evaluated for their suitability. This involves checking the question's syntax and grammar, ensuring it is well structured and easy to follow, and verifying that the mathematical reasoning is sound. The authors also note that human verification is still necessary to eliminate all potential failure modes. Despite these challenges, the authors observe instances where the models exhibit creative behaviors, such as considering the computational tractability of a question even when not explicitly asked to do so. They attribute this to the role-playing nature of the prompts, which allows the model to detect potential problems not explicitly accounted for in the prompts. The paper also discusses considerations for human annotators, who are tasked with double-checking the validity of the generated questions and solutions. Annotators are encouraged to look out for any of the failure modes discussed and to improve the question with respect to readability, quality, and difficulty. They are also asked to suggest changes that make the problem harder to solve using automated tools while retaining easiness for humans. Finally, the authors present a comparative analysis of model performances on generated data versus their performances on math, showing a quadratic relation between the two. They also observe that smaller models generally show larger degradation in performance as compared to their larger counterparts, with the exception of the Gemma family of models. The analysis of performance degradation on smaller models reveals that they generally experience larger relative performance declines compared to larger models in the same family. This finding aligns with conclusions drawn in Arora and Goyal, 2023, U et al. 2023a, which suggests that larger models are better at composing skills or concepts, a phenomenon known as compositional generalization. Figure 4b shows the comparison in relative performance drops between models of different sizes belonging to the same family. The generated dataset consists of 180 questions, each representing 2 skills, with a total of 97 skills out of the 114 skills extracted via the skill extraction process. Figure 5 shows the distribution of different skills in the generated set of questions, indicating that the distribution is not uniform, with multiple skills represented by only one question. The skill composition using different models is evaluated by prompting GPT-4 Omni, Claude 3 Opus, Gemini 1.5 Pro, and Llama 370B Instruct and Llama 38B Instruct to generate a question combining the skills area calculation skills and algebraic manipulation skills. The responses of each model to the prompt are provided, demonstrating their ability to generate questions that test both skills. The question generated by GPT-4 Omni involves finding the value of k, given the coordinates of q and r, and the area of triangle PQR. The solution requires algebraic manipulation and area calculation skills. The area of the rectangle ABCD is calculated as AB, and the area of triangle PQR is given as 1/6 of the area of the rectangle ABCD. The formula for the area of a triangle with vertices at x1, y1, x2, y2, and x3, y3 is used to find the area of triangle PQR. The solution yields two possible values for k, 2/3 and 4/3. The question involves area calculation by requiring students to find the area of a triangle within a rectangle, demonstrating the composition of skills in the generated dataset. The provided pages present three mathematical problems that test area calculation skills and algebraic manipulation skills. The first problem involves finding the area of a shaded region consisting of an equilateral triangle and three squares constructed externally on its sides. The solution requires calculating the areas of the equilateral triangle and the squares, as well as algebraically manipulating the expressions for side lengths and areas. The problem is calibrated to be similar in difficulty to provided examples, and the solution is a single numerical constant k. The second problem involves finding the area of a smaller circle inscribed in an equilateral triangle and externally tangent to a larger circle. The solution requires using the Pythagorean theorem and solving a quadratic equation with radicals to find the radius of the smaller circle. The area of the smaller circle is then calculated using the formula for the area of a circle. The third problem involves finding the area of a shaded region consisting of a square inscribed in a circle and a semicircle drawn inside the square. The solution requires calculating the area of the square and the area of the semicircle, and then subtracting the area of the semicircle from the area of the square. Key steps in the solutions include calculating areas of geometric shapes, algebraically manipulating expressions for side lengths and areas, and solving quadratic equations with radicals. The problems are challenging due to the involvement of nested radicals and the need for precise algebraic manipulation. However, the steps are all fairly standard, and the solutions provide a clear and logical flow of ideas. The problems are designed to test both area calculation skills and algebraic manipulation skills, and the solutions demonstrate a clear understanding of geometric concepts and algebraic techniques. The use of diagrams and visualizations helps to illustrate the problems and solutions, making the mathematics more accessible and engaging. Overall, the problems and solutions presented on these pages provide a comprehensive and challenging assessment of mathematical skills. The pages 23 and 24 of the research paper discuss the development of a system for generating math questions that test both algebraic manipulation skills and area calculation skills. The authors provide examples of questions and their solutions, as well as prompts for validating skill pairs and generating new questions. On page 23, the authors present a question that requires students to calculate the area of a region bounded by the curve y equals x squared 4x plus 3 and the z-axis, to the nearest hundredth. The solution involves integrating the function with respect to x from 0 to 2, which results in an area of approximately 2 square units. The authors also detail the prompts used in various stages of question generation and evaluation, including skill pair validation and question generation. For skill pair validation, the prompt requires the validation of a pair of skills by checking if they are essentially entirely the same or not. The prompt for question generation asks for the creation of a challenging math question that tests both specified skills, along with a brief solution. The authors provide examples of conversations between an AI agent and a teacher, which revolve around framing mathematical reasoning questions and using them for evaluating students. They also give 3 example question-answer pairs for both skills, ensuring that the complexity and difficulty of the skills in the generated question are similar to those in the example questions. Overall, the pages 23 and 24 of the research paper focus on the development of a system for generating math questions that test multiple skills, including algebraic manipulation and area calculation. The authors provide detailed examples and prompts for validating skill pairs and generating new questions, highlighting the complexity and difficulty of the task. The evaluation of mathematical reasoning abilities in students necessitates high-quality questions that assess expertise in multiple skills simultaneously. 2 skills, less than skill _1 greater than and less than skill _2 greater than, are considered, with example question-answer pairs provided to facilitate understanding. A question is presented, along with an attempted solution, to be validated based on several criteria. The criteria for validation include the single answer requirement, exact answer requirement, dual skill requirement, clarity and completeness, computational tractability, relevancy of information, realism and logic, and syntax and grammar. The question must ask for one final result, be solvable without approximations or assumptions, and require expertise in both less than skill _1 greater than and less than skill _2 greater than. The question should be unambiguous, contain necessary information, and be computationally tractable. The validation process involves reviewing the question and attempted solution, paying attention to how well they align with the example question-answer pairs for each skill. The complexity and difficulty of applying both skills in the question should be similar to or greater than the complexity and difficulty in the example question answers. The solution should not make any assumptions or approximations not explicitly stated in the question. The question is also evaluated for realism and logic, ensuring that the specified operations and contextual setup reflect plausible mathematical situations. The syntax and grammar of the question must be correct to prevent misinterpretation. Any problems in the question, such as logical inconsistencies or unnecessary complexity, are identified and accounted for. The validation process is challenging, and sample conversations between an AI agent and a teacher are provided to illustrate potential difficulties. The question to be checked and its attempted solution are presented, and a thorough analysis is required to justify a yes or no assessment of the question's quality and suitability for evaluating students on simultaneous application of less than skill _1 greater than and less than skill _2 greater than. The paper presents a comprehensive analysis of 2 mathematical skills, Skill 1 and Skill 2, with their respective sample questions and solutions. It also includes a new question that requires the application of both skills to solve it. The authors provide a detailed prompt for the final solution, emphasizing the use of in-context exemplars from Math, Hendrycks et al. 2021, as opposed to the attempted solution step. Skill 1 is described through 3 sample questions and their corresponding solutions, demonstrating the application of this skill in various mathematical contexts. Similarly, Skill 2 is explained with 3 sample questions and solutions, showcasing its relevance in different problem-solving scenarios. The new question posed requires the integration of both Skill 1 and Skill 2 to arrive at a solution. The authors encourage the use of prior knowledge and understanding of the skills beyond the sample questions provided. In the evaluation section, the authors outline a prompt for evaluating the model's solution. They task a professional math teacher with assessing student performance on a math exam, requiring them to compare the student's solution to the correct solution and determine whether the student solved the question correctly. The evaluation process involves a step-by-step explanation of the thought process followed by a yes or no answer indicating the correctness of the student's solution.